Let's look at what you need to know to install a CPU. A central processing unit, or CPU, is the electronic machinery inside your computer that executes instructions. Essentially, it is the brain of the computer. The CPU executes the instructions that controls all the other components that are connected to it. In order to make a CPU, a photomask is created. This contains all the circuits inside the CPU. Light is shone through the photomask to a silicon wafer. This wafer is used to create a CPU package. The CPU package is what we're interested in. The CPU package is built for a particular form factor and is generally referred to as the socket. This means that it can be used on motherboards that support that form factor. Further to this, certain CPUs support certain chipsets. Thus, it's important when purchasing a CPU to make sure it works with the motherboard that you're going to use. For the A+ exam, you're unlikely to get a question about how to install the CPU. As an IT technician, you'll need to know how to install one. Thus, this video content is more about giving you real-world skills rather than giving you knowledge for the exam. To start with, let's have a look at the Intel sockets used for CPUs. There have been a large number of Intel sockets released over the years. Since 2004, Intel has been naming their sockets with LGA followed by a number. LGA stands for Land Grid Array, which is a standard where the pins are on the motherboard socket rather than on the CPU. I will have a closer look into LGA later in the video. Following LGA is a number, which is the number of pins in the socket the CPU will connect to. CPUs with more connections or more pins mean more circuits to transfer data to and from. This generally translates to more lanes and larger data buses. I say connections in the case of Intel as the pins are on the socket of the motherboard. Let's have a closer look. Intel have released over 10 different sockets using Land Grid Array or LGA. You can see this on example CPU. The bottom of it is flat other than a few electronic components. Looking at the top of the CPU, you can see all the contact points under it. They're quite small and difficult to see. If you were to count them, it would add up to the number after LGA. In this example, the CPU is an LGA 1151, so there would be 1151 contact points. With current Intel sockets, there are no pins attached directly to the CPU. The pins for the CPU are located in the socket on the motherboard. Looking closely at the pins, you can see they are on an angle and look like they have a little hook at the top. What occurs is, when the CPU rests on top of the pins, the weight of the CPU pushes the pins down just a little bit. Since the pins are springy, they push back on the contacts under the CPU. This gives a very good connection between the motherboard and the CPU. LGA has the advantage that it's better at supporting a higher pin count and supports higher power delivery than using pins on the CPU. Having the pins on the motherboard does have its advantages, but also makes it easier for them to get damaged. In order to protect these pins from damage, the motherboard socket will have a plastic socket protector. Keep this protector, don't throw it away. This protector is needed for returns and to protect the pins if the CPU is removed. If you have a problem with your motherboard, the supplier most likely won't accept it for return without the protector. The pins in the socket are tiny and can easily be damaged. You can see in this example one of the pins is damaged. It's difficult to see. However, if you look closely, you can see the pattern of the pins is slightly different. When I look really closely, you can see that one of the pins is bent in the opposite direction to the others. It is possible in some circumstances to fix problems like this. In order to fix a pin like this one, you need a magnifying glass and a very steady hand to use a fine tool to push the pin back into place without bending any other pins out of place. This is a tricky process, and there's no guarantee of success. These pins are tiny, and even if they are a little bit out of place, they may not be able to connect to the contact points of the CPU. Even if just one pin can't connect to the CPU, this can make the CPU completely unusable. If your CPU still works, it may be unstable or not fully functional. Generally, if a pin is damaged, it means the motherboard will need to be replaced. The socket is also subject to dust and dirt. You can see in this example, some dust has got into the socket. The dust may not look like a lot, but when I zoom in, you'll see it's enough to cover one of the pins. In the worst case, this will prevent the pin from connecting. The dust may also make the pin connection unreliable, which could result in the computer being unstable and randomly crashing. With such small pins that are easily damaged, you can see why the motherboard has a socket protector to protect them. A single damaged pin can mean the motherboard will need to be replaced. Now let's look at how you can protect the CPU from damage. CPUs are vulnerable to electrostatic discharge. You should always use some precautions when handling them. This is a quick refresher, but we do have a whole video on this topic if you want to know more. If you have one, use an anti-static mat. An anti-static mat reduces the speed of static electricity trying to travel to ground. It also reduces the chances of static electricity jumping from you to the component. If you don't have an anti-static mat, the shipping box or another box works quite well. Some anti-static protection is always better than none. Rubber mats or cardboard are good because the soft surfaces won't damage the bottom of the circuit board. Static electricity occurs because the human body builds up a charge. When you touch something with no charge, the static electricity attempts to equalize itself with whatever is touched. To remove static electricity from yourself, use an anti-static strap connected to ground, either directly or via an anti-static mat connected to ground. If you don't have an anti-static strap, touch a metal part of the computer case. If the case is painted, touch one of the screws. Otherwise, touch something that's attached to ground. This will allow the static electricity charge to leave your body. After grounding yourself, you can still build up more static electricity, so don't be afraid to ground yourself again before touching any sensitive components. Now I'll start looking at how to install the CPU. Before installing the CPU, you'll need to work out the correct orientation. In order to do this, locate a small triangle on the socket. Either the socket or the socket protector will have a small triangle on one of its corners. In the case of this socket, the triangle is located on the bottom left. I have highlighted it to make it easier to see. On the CPU, there'll also be a triangle on one of the corners. When installing the CPU, it is a matter of lining these two triangles up. If you're not able to locate the triangles, there are other ways to determine the orientation. The socket also has protruding edges and blocked areas to prevent the CPU being put in the wrong way. You can see the protruding edges at the top of the socket. When I look at the CPU, you will notice at the top there are some notches. If for whatever reason your CPU does not have a triangle on it, maybe the triangle has faded and can't be seen. Look for these notches and it will assist you in knowing which way to put the CPU in. If you put the CPU in the wrong way, you risk damaging the CPU or the motherboard. When working with electronics, you'll hear the term zero insertion force or ZIF. ZIF in electronics means zero force is required when putting in components or cables. CPUs are well known for being ZIF sockets, but it also applies to cables that don't require any force. Usually these cables are ribbon cables located on the circuit board. If it requires force, it's not a ZIF socket. In the case of LGA, the retaining plate holds the CPU in place and thus holds it against the contact pins, making sure there's a good connection. Now let's have a look at how to install an Intel CPU. To install the CPU, I first need to locate the triangle so I can match it up with the CPU. The protective cover is over the socket, blocking the triangle on the retaining plate. But notice that there's a triangle on the protective cover. It can be a little hard to see, but check the corners. It'll be there somewhere. To install the CPU, the retaining plate needs to be opened. To do this, press down on the lever. Move it to the side and pull the lever upwards. The CPU is now ready to be installed. This CPU has been used before and still has thermal paste on it, so I will use an alcoholic wipe to clear the thermal paste off. I've put some gloves on to help reduce the chance of electrostatic shock to the CPU and also to protect myself in case I get any thermal paste on me. Thermal paste is not very toxic, otherwise it would have warning labels on it. However, it does contain metals in it which are best not to ingest. If you do get some on yourself, don't worry, just wash it off with some soap and you should be fine. It's not recommended to leave old thermal paste on a CPU. Thermal paste is cheap and you don't need a lot. It's also not recommended to mix different brands of thermal paste together. Once I've cleaned the paste off, I will now install the CPU onto the motherboard. I need to make sure that the triangle on the CPU is lined up with the triangle on the socket protector or the retention plate. Once this is done, lower the CPU into the socket. Don't use any force. Gravity should be enough to have the CPU sit flush in the socket. Once the CPU is in the socket, put your finger on top and give the CPU a small wiggle using minimal force. You don't want to push down on it, just move it to the sides slightly. To understand why we do this, I've put the CPU in the socket incorrectly. The CPU is not fully in the socket and you can see it is at an angle. If you see this, remove the CPU and put it back in again, but for the purposes of the demonstration I've done this on purpose. Giving the CPU a gentle wiggle causes it to fall into the socket. If the CPU is even a little misaligned, giving it a wiggle will fix this. If it's too far out of alignment, wiggling the CPU may drag the CPU across the pins, which can cause damage. Thus, if you see it's not in the socket, pull it out and try again. Don't wiggle the CPU too hard. You're simply doing this to test the CPU is in the socket correctly and correct any minor alignment problems. If you wish to check the CPU is in the socket correctly, have a look at the keying and that the triangle is in the correct location. If you try putting the CPU in the wrong way, it's pretty obvious because it won't fall into the socket due to the keying of the CPU. This is another reason why it's important not to force a CPU into the socket. The next step is to close the retaining plate. To do this, move the retaining lever and the retaining plate back. I've broken this into 2 steps to explain what's happening, but once you've done it, you'll probably be able to do this in 1 step. I'll pull the retaining lever back, so the retaining plate goes under the retaining screw. Then push the retaining lever down and lock it into place. The protective socket cover should pop out and it can be removed. The next step is to attach a CPU cooler. Modern CPUs are designed to run with the CPU cooler. If you don't attach one, they'll start overheating in as little as a minute, even if not under load. In this demonstration, I will use a standard Intel CPU cooler. This one already comes with thermal paste applied. There's no need to add any more. Later in the video, I will look at how to apply thermal paste if the CPU cooler does not have any pre-applied. When taken out of the box, the power wires for the CPU cooler may block or restrict the movement of the fan. To prevent this from occurring, I'll generally pull out at least the first part of the wire from the CPU cooler. If you find more is blocking the CPU cooler, or you think it may block it later, I would pull it out. You don't want to have to open the computer later on to remove the wires because the fan either stopped or was being slowed down. On top of the CPU cooler there are 4 push pins, 1 on each corner. I will have a closer look at one so we can understand how they work. Each push pin has an arrow on the top. This arrow indicates which way the push pin needs to be rotated to be put into the reset position. In the reset position, the pin inside the push pin can move in both directions, rather than just in the downward direction. Currently, the push pin is in the locked position. When I push down on the push pin, you'll notice the internal black pin will be pushed through to the other side. It pushes the white plastic outwards, which holds the push pin in place. This is what holds the CPU cooler in situ. When the push pin is in the locked position, you'll notice that I'm not able to pull the push pin up and thus release it. If I want to pull the push pin up, I first need to turn the push pin to the reset position. Once it's in the reset position, I'm able to pull the push pin up. You'll notice that when the push pin is in the reset position, I can still push the pin downwards. The CPU cooler I'm going to install has 2 of the push pins in the reset position. It's generally easier to put them in the secure position before the install, but it can always be changed afterwards. Before I install the CPU cooler, I first put all the push pins in the secure position. I need to first check that none of the push pins have been pushed through already. Notice this pin has, so I'll push it back up and then turn the push pin to the secure position and also turn the other push pins to the secure position. To install the CPU cooler, I'll first work out where the CPU fan connection is on the motherboard. It'll be written on the motherboard, but if you have trouble finding it, you can always look in the manual. I want to know where this is, so that I can orientate the CPU cooler to use the least amount of wire. There are a number of fan connectors around the motherboard. Some are for other purposes, such as a fan for the computer case. Make sure you choose a CPU fan connector, otherwise the computer won't be able to control the fan speed correctly because it will think it is a different fan. I will now place the CPU cooler over the CPU. The first location won't have enough slack in the power cable to reach the connector on the motherboard, so I'll rotate the CPU cooler 90 degrees and try again. The CPU cooler is in a good position now with cable management in mind. You want to reduce the possibility of the cable getting stuck in the CPU fan or other fans in the computer. I will next move the CPU cooler around until the push pins fall through the holes into the motherboard. If a push pin has already been pushed through, it will not be able to fall through. Thus, it's important to check first. With a new CPU cooler, this shouldn't be the case, but if you're using a used one, it's best to check. To make sure all the push pins are in place, you can give the CPU cooler a little bit of a shake, not too hard, and you should be able to feel that the push pins are in place. The next step is to push the pins down. This will hold the CPU cooler in place. You just need to push them down until you hear a click. To keep the CPU cooler stable when pushing the push pins in, it's best to push diagonally opposite pins in at the same time. If you ever need to remove the CPU cooler, all you need to do is get a flathead screwdriver, turn each push pin to the reset position and lift it upwards. The last step is to plug the CPU fan into the motherboard so it can get power. You'll notice that there are 4 wires that can easily get separated and get into a place they should not be. To manage this better, I'll put a few twists in the cable to keep all the wires together, making it easier to manage. This will help prevent any cable blocking fans or getting somewhere it should not be. And that completes the installation of an Intel CPU. Now let's have a look at how to install an AMD CPU. Shown here are 2 of the current AMD CPU sockets on the market. There have been more than 10 different sockets released by AMD since 1999. In this video, I will only be looking at the AM4 CPU socket. The AM4 is the most common socket currently on the market. The TR4 socket is for high-end and server systems. There's also an AM5 socket on the market, however, since it's similar to the Intel CPU I just looked at, I won't look at it now. The AM4 socket uses a different type of socket than the current Intel ones. The TR4 uses a socket that is similar to that of the Intel socket we just looked at. Let's have a closer look. The majority of AMD CPUs use pin code array or PGA for their CPUs. This essentially means the CPU connects to the motherboard using pins in the CPU. There are a lot of pins coming out of the CPU, and you can see these pins are very small. High-end performance CPUs like the Threadripper and some of the AMD Ryzen CPUs use LGA rather than PGA. The motherboard has a socket for the CPU which has socket holes that the CPU goes into. For each of the pins on the CPU, there'll be a socket hole for that pin. The socket holes are essentially made of plastic to prevent the pins being damaged. However, if dirt or dust get into them, this can affect the connection to the CPU. As with the Intel socket, it is a zero insertion force socket. Intel originally used PGA but have since switched to LGA. AMD has started using LGA, their high-end performance CPUs, including those targeted at the consumer market. If I were to take a guess about what's going to occur, I would say that AMD will start making the switch to LGA. Here's an example PGA socket. It's an older socket with less pins, so it's easy to see what is happening. You'll notice that the socket cover has a large number of holes. Under the socket cover are the contact pins. You'll notice that when the lever is pushed downwards, the socket cover moves. The socket cover essentially moves the pins of the CPU so they make contact with the pins below the socket, thus locking them into place. Now let's have a look at how to install an AMD CPU. As before, I'll use anti-static measures to make sure that I don't accidentally damage the CPU. The first thing I need to do is lift the retaining lever. To do this, push the retaining lever down, move it to the side, and lift it up. The next step is to put the CPU in the socket. Just like the Intel CPU, I'll need to locate the triangle on the CPU to make sure that it's orientated the correct way. You'll notice on the bottom of the CPU there are pins on the CPU rather than being flat like the Intel CPU. When I place the CPU next to the socket, notice that there are a number of pins missing. These are missing to ensure that you don't put the CPU in the wrong way, so make sure you never force the CPU in, because if it's orientated incorrectly, it'll damage the pins under the CPU. I will now lower the CPU into the socket. You need to make sure that when you do this, the triangle on the CPU and the socket are lined up. On some sockets, it may be difficult to find this triangle. If you are having trouble, have a look in the motherboard manual. You'll want to make sure that you complete this step correctly. Once you have the triangles lined up, the next step is to lower the CPU into the socket. When lowering it, you may need to move it around a little to line the pins up. Once they're lined up, the CPU should fall into the socket. Don't use force, let gravity do the work for you. The next step is to lower the retention lever and lock it into position. Simply lower it down, move it slightly upwards, and move it back in under the locking mechanism. The next step is to put on the CPU cooler. On the motherboard, there are 2 retention hooks. These are designed to hold certain types of CPU coolers in place, although they tend to be the older types. I have an older CPU cooler that has hooks on either side that clamps onto the retention hooks. I won't be using this one with the current CPU because it's not designed to efficiently cool a high heat generating CPU like this one. Instead, I'll use it to demonstrate the installation process of this type of CPU cooler since it's easy to see and understand the process. If I was using this as a production system, I would get a CPU cooler that's designed for a CPU of this type. The motherboard features 2 retention hooks meant to secure specific types of CPU coolers, typically older models. My older cooler has corresponding hooks that clamp onto these, but it's not suitable for efficiently cooling the CPU as it generates more heat than this CPU cooler is rated to handle. Therefore, I'll use it solely in this demonstration for visual clarity of the installation process. For real-world use, however, I recommend a CPU cooler rated high enough for the CPU you're using. Before proceeding, let's have a look at how to apply thermal paste. There are a lot of different opinions about applying thermal paste. I'll first explain what thermal paste does and show you the method that we recommend. It's applied between the CPU and CPU cooler and provides an efficient way to transfer heat between the two. To understand why, consider that a CPU and CPU cooler surfaces may look and feel flat, but in reality they have microscopic imperfections that prevent the surfaces making good contact with each other. This results in poor heat transfer between the two. Good heat transfer between the two because the CPU cooler is essentially pulling heat out from the CPU and dissipating it into the air. Thermal paste fills the gaps between the two, providing a good transfer of heat between them. Without thermal paste, there's no good transfer of heat, and the CPU will run very, very hot, potentially overheating and fail. Let's now look at how to apply it. The method that we recommend for applying thermal paste is what is often called the pea method. This is when you put a blob about the size of a pea in the middle of the CPU. I will look in more detail at why we recommend this method over the others shortly. There are other methods people use, some of which are shown here. There are plenty of videos where people use different methods, and generally in their testing they'll find a couple of degrees difference. This could be for a lot of different reasons, but you'll find that some people swear by a particular method being better than others. The testing does show significant differences between using thermal paste in any pattern over using no thermal paste, so the important takeaway is to use thermal paste. The next method I refer to as the coffee method. This is when people start getting a bit too creative with the patterns they make with the thermal paste. I call it the coffee method because it starts to look more like the patterns you may find in coffee made in certain coffee shops. This method is not recommended, as it's very random how the paste ends up being applied. The last method I call icing the cake. I don't recommend this method. The reason I don't recommend this method is that when you apply the CPU cooler, the thermal paste will spread out, and it's all too easy for extra thermal paste to leak over the side of the CPU. Some thermal paste does conduct electricity, so if it gets onto any of the electronics, it can cause malfunctions or damage. If it gets into the pins or socket of a CPU, it's very difficult to get out again. You don't want to replace a motherboard or CPU because the thermal paste got onto somewhere it should not have been. Results show that when no thermal paste is used, the CPU runs very hot. Different applications of thermal paste only produce small differences in temperature. I will now look at why we recommend the P method over other methods. To understand why we recommend applying thermal paste using the P method, consider a CPU broken down into its basic components. The main part of the CPU is the CPU die. You'll notice compared with the printed circuit board it's installed onto, it's very small. The heat from the CPU is generated by the CPU die. When you look at the CPU from the top, the die is generally in the center. Thus, all the heat is in the center of the CPU. Some CPUs may have multiple dies, but even in those cases, all of them are in the center of the CPU. On top of the CPU die is a heat spreader. The job of the heat spreader is to pull the heat away from the center of the CPU. Thus, you can understand why I want to ensure that there is thermal paste in the center of the CPU, since this is what generates all the heat. The heat spreader effectively draws heat away from the center. Thus, having the thermal paste centered on that area ensures that the area has good coverage. As you move away from the center, there's less heat, and thus if there's not such good coverage, it has less effect. Now let's have a look at what happens when we apply thermal paste to the CPU. I will now apply some thermal paste. In this example, I will use the P method. You simply need to apply a blob of the paste to the middle of the CPU, about the size of a pea. I will now put a piece of plastic on the CPU so we can see what happens. I'll push down a little and move it around to simulate the CPU cooler being put on. You don't want to push down too hard, but applying some force is fine. I will remove the plastic so we can have a better look at the thermal paste. You'll notice that there's a bit of space around the edges of the CPU. So in this case, I will add a little more thermal paste and put the plastic back on the CPU. The thermal paste is spread out a little more, giving me better coverage of the CPU without going over the sides. When you're installing a CPU cooler, don't be afraid to remove the CPU cooler and see if you need a bit more thermal paste. Some thermal pastes will come with a spatula. You can use this to apply and spread the paste out. I personally don't use one, as I find a lot of thermal paste tends to stick to the spatula, making it hard to use, but you may find that you prefer it. If you do use it, leave some space around the edges of the CPU so thermal paste does not spill over the side. You're not icing a cake, and remember the paste will spread out when you put the CPU cooler on. Let's now have a look at how to put on the cooler. Before installing the CPU cooler, I want to first work out which way to orientate it. In the case of retention clip coolers, you can only orientate them in one of two different ways. I'll place the CPU cooler on the CPU. I want to work out which is the best way to orientate it in order to manage the cable for the CPU fan. I'll plug the CPU power cable into the motherboard, which allows me to work out the best orientation for the CPU cooler. You'll notice the power cable is over the memory modules, so I'll rotate the CPU cooler around. Notice the cable now fits nicely in an area of the motherboard where there are no serviceable parts. If you can avoid it, you don't want to have cables blocking memory modules, video cards or storage connectors. I will next need to apply the thermal paste. First, I will remove the CPU cooler and then we'll apply some thermal paste to the CPU. I will try to make it about the size of a pea, but in this case, I have accidentally put a little bit more on than I wanted to. I'll now put the CPU cooler on the CPU. I want to push it down a little bit to spread the thermal paste around, and then I'll remove the CPU cooler to see how well it has spread. You don't necessarily need to do this step, but I like to make sure the thermal paste spreads out in the Goldilocks zone, not too little and not too much. You'll notice that the thermal paste spreads out, but some got a bit too close to the side for my liking, so I'll remove the excess from the side. It's not too bad and you can leave it, but I don't like to risk the thermal paste spilling over the sides of the CPU. I'll now replace the CPU cooler. The next step is to secure the CPU cooler so it does not fall off. There are two clips that need to be secured. I'll start with the one on the CPU that does not have a lever. All you need to do is push the clip down and then pull it up so it's under the retention clip. This will lock on one side of the CPU cooler. I'll first need to push the retention lever to unlock, move the clip under the retention clip and move the lever back to the lock position. The CPU cooler is now locked into place. These CPU coolers are not too hard to install. I will now tidy the fan cable up a bit. You'll notice the four wires will easily come apart, meaning they can get stuck in places they should not. So I'll unplug the cable, give it a few twists and then plug it back in. Once done, notice how much better the cabling is than before. I will now have a look at how to install a CPU cooler that uses spring screws. This one has 4 spring screws. It has come with thermal paste pre-applied. In this demonstration, I won't be installing the stock CPU cooler, but instead installing an aftermarket version to give us a bit more of a challenge. If your CPU cooler has thermal paste pre-applied, I would recommend leaving it on the CPU cooler. There's no need to add any more, and I would not recommend mixing 2 different types. If you find the thermal paste is not intact or old, I would remove all of it and start again. The CPU cooler that I'm going to use is able to provide better cooling than a stock one. However, you will notice that it has a lot more parts and it's a bit harder to install. In most cases, the CPU will come with a stock CPU cooler. In the case of larger CPUs, a stock cooler may not be supplied with it. These CPUs generate a lot of heat, and the standard CPU coolers won't be able to keep them cool enough for them to run efficiently. If you purchase one of these CPUs, make sure you purchase a CPU cooler that's designed for a CPU of that size. There are many on the market, and of course, some work better than others. These CPU coolers are designed to run on as many CPUs as possible. Thus, they come with parts designed for Intel and AMD CPUs. Look for markings or labels which indicate which CPUs they are designed to be used with. In some cases, there are parts that need to be adjusted depending on the CPU used. In the case of an Intel CPU, this backing plate will need to be adjusted depending on the CPU that you're using. This CPU cooler does not come with an AMD backing plate, as it uses the one that comes with the motherboard. This brings us to an important point. You'll notice that without the screws holding the backing plate in place, the backing plate has come loose. If you're having trouble installing a CPU cooler, check to make sure that the backing plate is still intact, as without it, the CPU cooler has nothing to screw into. Although the backing plate that came with this motherboard will work fine with this CPU cooler, in some cases you may need to change the backing plate. For example, some water coolers may require a different backing plate. Before I can start installing the CPU cooler, I first need to attach the AMD bracket to it. Ensure that you use the correct bracket for your CPU. In this case, the bag is labeled AMD, which makes it easy. Otherwise, have a look at the instructions for the design of the bracket and choose the one that looks like the bracket in the instructions. The next step is to make sure that the bracket is facing the right way. In the case of these brackets, it has a protruding edge, which needs to face the protruding edge on the other bracket. Check with the instructions for your CPU cooler to determine which way the bracket needs to be put on. I will now attach the brackets to the CPU cooler. When putting them on, make sure that they're facing the correct way. In this case, facing inwards. The 4 screws need to be put in to hold the 2 brackets in place. These need to be firmly in place to help ensure that there's a good connection between the CPU and the CPU cooler. There's one more adjustment that needs to be done before I can install this CPU cooler. For this motherboard, the screws in the bracket need to be put in the outward position. If they're not in the correct position, the CPU cooler will not fit in the motherboard. I will now remove the CPU cooler and put the motherboard back. Before I can put on the CPU cooler, I need to replace the backing plate. It's just a matter of putting it back in the motherboard. If your motherboard is in a computer case, you may need to remove the backplate of the computer to reach it. In this case, the desk will hold it in place for me. However, if the motherboard was in a computer case, you may need to hold it with your other hand while putting the CPU cooler in. Once you have one screw partially in, this will be enough to hold it in place until you can get all the screws tightened. You'll notice that I have 2 different ways of orientating the CPU cooler. We don't have any cables to worry about yet, thus it does not matter which way I orientate it. Before I install the CPU cooler, I need to remove the protective sticker from the bottom. It's important to always check for protective stickers or packaging before installing components, particularly devices like these that get hot. I will next apply the thermal paste. I applied a little too much last time, so I'll try and apply a little less this time. Once again, I'll use the P method to apply it. I will next put the CPU cooler on the CPU. When I apply thermal paste, I often like to pull the CPU cooler off to see how it's applied. In this example, this was not a good idea. Have a look at why. Notice how runny the thermal paste is and how, in lifting the CPU cooler, thermal paste dripped onto the motherboard. I used what came supplied with the CPU cooler. Most thermal paste is not this runny, but it just goes to show you how different manufacturers make thermal paste differently. If you do plan to check if the thermal paste was applied okay, be careful when lifting the CPU cooler, so nothing drips onto the motherboard. I've cleaned the thermal paste off the motherboard. Notice that the paste has spread out a little. It doesn't seem to be enough, but when I screw the CPU cooler on, it'll spread out more. So to see the results, I'll remove the CPU cooler afterwards so we can see how much it has spread out. For the next time, I'll be careful not to drip thermal paste onto the motherboard again. I will next screw in the first spring screw to hold the CPU cooler in place. To screw in the first screw, push down on it and screw it in a few turns before moving on to the opposite side. You can see the force of the opposite spring screw has caused this one to pop upwards out of the screw hole. This is why we need to apply a little downward force on the spring screws. However, we don't want to screw the spring screw in all the way at the start, as it will elevate the other spring screws. I will screw in the other 2 spring screws. Once again, you want to push down a little bit and screw them in, but not all the way yet. Once all the screws are partially in, I'll go back to the first and screw it in the rest of the way. When the spring screw reaches the bottom of the backing plate, you'll feel it hit. When you feel this, stop screwing. I will now screw in the rest of the screws. You just need to screw them in until you feel that each of them has reached the bottom of the backing plate. They'll push the CPU cooler down on the CPU and make contact with it. This will help transfer the heat from the CPU to the CPU cooler. While you were not looking, I took the CPU cooler off so we could have a look at how the thermal paste spread out. You'll notice that with the amount we put on, it spread out pretty evenly across the CPU. You can see that you don't need a lot of thermal paste, and also why we recommend the P method over any others. As long as you use the right amount, it works pretty well. The next step is to attach the fan. The fan comes with 2 fan clips which are used to connect to the CPU cooler. This fan also has some long cables, so we'll have to look at how to manage them. These fans are designed to push air through a resistance, such as case meshes, radiators, or in this case, a heatsink. You'll notice that when I compare it with a case fan, there's less of a gap between the blades. Less gap means more airflow but less pressure to push air through any resistance. Thus, for optimal performance, you want to use the left fan for devices like a CPU cooler and the right fan for a computer case. Given that the technology for fans has improved, there are now some pretty expensive fans on the market. Some manufacturers have gone for a hybrid fan rather than making different fans for different purposes. These fans are a trade-off between airflow and air pressure, giving both reasonable airflow and pressure. Thus, these hybrid fans can be used for any purpose and give reasonable results. Given that many computer cases have filters in the computer case, having some air pressure behind the fan is helpful. Thus, you can see why hybrid fans are becoming more common. I will next install the CPU fan. I first need to work out which way the air is flowing through the fan. The open part of the fan is where air comes in, while the other part with the holding frame is where air comes out. On your fan, hopefully there's an arrow which will point in the direction of airflow. This may be on all sides of the fan, or only one side if it's there. I will now put the fan in the location that I will mount it to the CPU cooler. If you find that it is blocking components, for example the memory modules, you can always mount the fan a little higher. This is not optimal, but in some cases you may not have a choice. In the case of this motherboard, you'll notice that I'm able to access the memory modules when the fan is directly in front of the cooler. It's a little bit of a squeeze, so if I was building a computer, I would put the memory modules in before installing the CPU cooler. I will now place the fan on the other side of the CPU cooler. The fan once again will be orientated so air is being pushed into it. To understand why this is not a good idea, I've magically put the motherboard into a computer case. You'll notice that the case fan is pulling air out of the computer and the CPU cooler fan is pulling air from the case fan into it, so they're working in opposite directions. This is far from ideal. Good computer design has cold air being drawn from the front of the computer case and blown out the back of it. Any fans inside the computer case should, whenever possible, match the direction of airflow. I could reverse the orientation of the fan so that it is facing the other direction. The problem with this is the fan is optimized to push air through the CPU cooler. Although it will work, the result won't be as good as if it's mounted on the other side. You'll notice that the CPU cooler sits pretty high up in the computer case, but does not block the side panel. This is not the biggest CPU cooler you can get. It should fit in the standard sized computer case, but with the smaller computer cases it won't. When you purchase any aftermarket cooler like this one or a water cooler, make sure your computer case is big enough for it to fit. Now let's mount the fan onto the CPU cooler. First I need to work out where the cables from the fan plug into the motherboard. In the case of this fan, there's a power cable and an addressable RGB cable. Thus, there are 2 connectors on the motherboard. Lucky for us, both of them are together next to the memory modules. This gives us a few options for cable management. The first thing that I need to do is attach the CPU clips. These clips hold the fan on the CPU cooler. To do this, lift the fan clip up under the fan so that the ends of the metal clips go through the holes in the fan. This will need to be done on both sides. The next step is to attach the fan to the CPU cooler. To do this, place it in the position that you want and pull one of the fan clips back. Hold it close to the CPU cooler and release it. The CPU cooler has protruding edges on it designed to catch the spring-loaded fan clips. The same needs to be done for the other side. Once both fan clips have been done, this is enough to hold the fan in place. The next step is to plug in the two cables going to the fan. I'll first plug in the addressable RGB cable. You'll notice there are two connectors, one with a cap on it. The other one under the cap connects to the next addressable RGB device. Thus is a pass-through connector. The connector has 4 pins with one blanked out. I will now plug it into the motherboard. The motherboard may also have an RGB connector. You can see on this motherboard the RGB connector is next to the addressable RGB connector. They both have a 4-pin connector, however the RGB connector is not keyed. Thus, if you're using an RGB connector, you can plug it in the wrong way. You can also plug it into the addressable RGB connector. Be careful not to do this because they are wired differently and use different voltages. I will next plug in the fan power connector. For this fan, the connector is a 4-pin connector. You can also get fans that use a 3-pin connector. Motherboards nowadays generally support both types. If you have a choice, I would personally get the 4-pin connector nowadays, since they can draw more power and the computer can control the fan speed better. I will now plug the connector into the motherboard. The only thing you need to be careful of is to plug it into a CPU connector. The case fan connectors and other fan connectors on the motherboard all use the same type of connector, so it's easy to get it wrong. I'll do a small amount of cable management just to get you thinking about what options you may have. If I was using this computer case, I would most likely pull the extra cable under the back plate of the motherboard or somewhere out of the way. Here I will use a cable tie to tie the cable to the fan. I'll cut off the excess cable tie, just making sure not to cut any cable. It doesn't look the greatest and I could spend more time making this neater. The important point to take away is, if you manage the cable like this, make sure the cable is away from any fans it could get pulled into, and off of any hot edges. The fan casing doesn't get hot, but the heatsink does, so you want to keep the cables away from that. This CPU cooler supports a second fan. Also, it comes with fan clips to mount a second fan. I wasn't able to get a second fan to match the other one as the supplier was out of them. So, for the purposes of the demonstration, I will use a fan from a different manufacturer. I would recommend using a fan from the same manufacturer if possible. As we'll see, the fans work as a pair, and different manufacturers' fans may spin at different speeds. Personally, I wouldn't worry about a second fan unless the CPU cooler came with one originally. Basically, a second fan takes the load off the first fan, meaning it does not need to work as hard. As a consequence, the computer will slow the fans down. In some cases, this may make the computer a little quieter, since the fans won't be spinning as fast. It doesn't have much effect on CPU temperature, since the computer will actively speed up or slow down the fans depending on the temperature of the CPU. This fan does not have any markings to indicate which way the air flows. If you forget the open side is the intact side, you can always give the fan a spin and use your hand to feel the air flow. Just make sure you don't put your fingers in the fan. Computer fans spin anti-clockwise, which is the opposite direction to most domestic fans. As before, I will attach the fan clips to the fan. Once these are attached, I will attach the CPU fan to the CPU cooler as before. When you attach the fans, it's important to make sure that they are orientated correctly, so the airflow gets through the CPU cooler. If both fans are facing in opposite directions, you won't get any airflow through it. I will next need to plug in the power and the addressable RGB plug. Since there's only one CPU power connector on the motherboard, I will need to use a power splitter. This power splitter divides one connector into 3, but we will only use 2. Since both fans will be running off the one cable, the computer will consider them to be the same fan. This is why it's a good idea for CPU coolers like this one to use identical fans. Mismatched fans can cause extra stress which can reduce their lifespan. To install the splitter, I will remove the existing power plug and plug the splitter in. I will then plug it into the first fan. I will next plug the second fan into the other connector on the splitter. Both fans are now connected to the motherboard. I won't worry about doing any more cable management in this demonstration, since normally I would be installing the motherboard in a computer case and most likely would do some cable management as part of that. Next, I'll plug in the addressable RGB cable. I don't need a splitter in this case because the fan comes with a pass-through connector. It's just a matter of removing the cap and plugging in the cable for the second fan in. And that's it for installing a CPU. I'm now going to have a look at what you need to consider before purchasing a CPU. When selecting a CPU, you need to ensure that you select one that's compatible with your motherboard. The best way to do this is have a look at the manufacturer's website. They'll have a list of CPUs the motherboard supports. In some cases, you may need a certain BIOS version to use that CPU. Hopefully, you won't get caught in a chicken and egg situation where you need a BIOS upgrade to use a CPU, but can't use the CPU until you upgrade the BIOS. This does not happen as much as it used to. That's why, when possible, I like to buy the motherboard and CPU from the same supplier. If there is a problem with the CPU and a motherboard not working, hopefully you can return it and they'll be able to fix it. You'll find that there are probably a number of different CPUs you can choose from. Let's have a look at what to consider when purchasing one. To understand what features the CPU has, it helps to understand the naming convention that is used. In the case of Intel, it starts with the brand of the CPU. The most common on the market currently is Intel Core. For higher performance, there's the Intel Xeon. The Xeon CPU is designed for high-performance workstations or servers, so you can see how this may already guide the choice of which processor you purchase. You may also come across Pentium and Celeron CPUs. There are also other older brands. The Celeron processors run at lower speeds and have less cache, thus cost less than the Pentium, but performance is also less. The next part is the tier. These are i3, i5, i7 and i9. I believe this was done for marketing reasons. Naming them this way sounds better than naming them 1, 2, 3 and 4. So don't be concerned about understanding how they came up with this naming convention. The takeaway is that generally higher numbers give better performance. Higher performance often means more power use. Therefore, you may find that an i3 is used in cheap laptops where power consumption is important. CPUs like i9 get used in high-performance systems. You'll often find CPUs higher up the tiering will have more features, more cache, and support more lanes than the lower numbered ones. Generally, higher spec CPUs will perform faster, but there are exceptions to this. For example, if you purchase the newest and the best i5 you can get, this may outperform an older, lower spec i7. The next part of the naming convention is CPU generation. As time goes on, Intel often makes major changes to the way CPUs work. These changes are grouped together into a generation. The lower generation numbers are older and the higher are newer. Normally, newer generations will perform better, but unfortunately, which is often the case with computers, it's not always that simple. Intel will at times optimize and improve a generation. For example, redesigning the CPU's microarchitecture. The microarchitecture is the internal design inside the CPU that determines how instructions are executed. This means it's possible for a redesigned older generation to outperform a newer generation. Thus, it's also important to consider what microarchitecture the CPU is running. As you progress through generations, regardless of how much faster an older generation is, it won't surpass the capabilities of a newer generation once that generational gap becomes substantial. The next part of the name is the model. This is assigned when released. The model numbers map to the tier of the CPU. Thus, looking at the model number, you can determine what tier the CPU is. New CPUs will generally have a higher model number, but this doesn't necessarily mean it's better. For example, a later released CPU may be designed to have less power consumption. Less power consumption often comes at the cost of performance, so don't assume a higher model number is necessarily better. The last part of the naming convention is letters to indicate features. For example, if the name ends with an F, you will need to purchase a graphics card, as the CPU does not have graphics capabilities. You'll also notice letters to indicate if the CPU is optimized to use less power or performance. As you can see, you can get a general idea of what kind of performance you can get, but there's a lot to take into consideration which may affect the results. Let's look at another way to determine which CPU to buy. One way I like to compare CPUs is to use CPU charts. For example, the ones available from Tom's Hardware. These charts show the test results for a number of different CPUs with different test conditions to find out how they'll perform. You can see at the top of the chart for this test anyway, the top 4 include an i9, i7 and i5. Looking at charts like this will give you a good idea what you can expect from the CPU. Notice, however, that the price goes down as performance goes down. If you're purchasing a new CPU, the price usually goes up pretty consistently with performance. Now let's have a look at the AMD naming conventions. To start with, I'll look at the old naming convention. I say old because AMD has released a new naming convention that it will start following from 2023 onwards. The old naming system is very similar to that of Intel, so it should not be too hard to follow. AMD's main CPU is the Ryzen. If you want better performance, AMD offers the Threadripper, although it does still come under the Ryzen product line. For servers and workstations, AMD has the EPYC line of CPUs. These CPUs use less power, have better security to prevent data breaches, and are designed for server applications. Since these are specialized CPUs, you'd only use them in servers and certain workstations. For desktop computing, you'd stick with the Ryzen product, including the Threadripper if you can afford one. You may also see Athlon CPUs. This is an older product line and is being replaced by Ryzen. Thus, you'll only find it in older computers. For the tiers, there are 3, 5, 7, 9 and Threadripper. Generally speaking, the higher the tier, the better performance you can expect, and the lower the tier, the cheaper the CPU will be. AMD has generations like Intel does, but doesn't release new generations as quickly as Intel does. The model number can once again be matched to a tier. Thus, everything so far is pretty similar. AMD CPUs also have a suffix on the end that indicates features. Unlike Intel, there are not that many of them. If the AMD CPU ends with an X, this means that it runs at a high clock rate. For example, a 5700X will run faster than a 5700. AMD CPUs by default don't come with graphics like Intel. Thus, if you want graphics, you need to look for a CPU that ends in G or X3D. So now let's have a look at AMD's new naming convention. Shown here is the new naming convention for AMD CPUs starting from 2023. It's very different from the old system, but is designed to make it simpler to compare different CPU processors together. The big difference is that the first digit represents the year the CPU was released. CPUs get better as time goes on, thus comparing the year it was released is a good indicator of performance. The next digit, market segment, replaces Ryzen 3, Ryzen 5, etc. Notice a return of the Athlon name for the lowest performing CPUs. The next digit is the architecture, referred to as Zen. This is effectively technically the same as a generation. Feature isolation represents the performance of the CPU. Higher numbers mean the CPU performs faster. Lastly is the form factor, which essentially determines how much power the CPU will use. If you want even more information about a CPU before you make a purchase, there's more available. Intel and AMD both have additional information about their CPUs and other products on their websites. Both will provide information such as the number of cores, threads, power usage, and a lot of other stuff. If you need more information about the CPU before your purchase, these are the websites to go to. I hope this video has helped you install a CPU and also make some good decisions about what kind of CPU you should purchase. Until the next video from us, I would like to thank you for watching.